Did you have anyone show up last week?
No, nobody. And
I missed, oh man.
I don't know.
Missed Wednesday.
Yeah, so Wednesday we didn't have anything, but we were posting stuff, so. All right, so let's talk about the idea in 3.2. So that's where we're at right now. So and maybe we'll cover a little 3.2 and 3.3 because since we only do this twice a week, we've got to kind of handle 2 days worth of material. Or if we're doing this, again, the purpose of this is not to be the primary source of you learning the material. This is mostly, hopefully, to answer your questions if you've got it. But if not, we'll use it for what we've got it. So let's talk about these. We're talking about logarithmic functions. So these are new kinds of creatures here. You seeing that all right and hearing me okay and all that stuff?
Yeah, it's all looking good.
Okay. All right, so logarithmic functions, here's what they look like. We actually use the word log base A of x. Okay, so these are related to exponential functions. Okay, remember exponential functions have a base, and so logarithmic functions have a base, and we have some requirements. The base, just like with exponential functions, the base has to be greater than 0 and not equal to 1. Okay, so we can have, f of x equals log base 2 of x, or g of x equals log base 4 of x, right? Any base you want, right? But now, the thing about these functions, when you see them like this, we have no idea what mathematically is going on. So here's what you need to know about how a log works mathematically. So I'm going to go back to using y's instead of f of x. So if we have the function y equals log base a of x, what you need to do in order to understand the math behind it is you need to transform it into this form. A raised to the y power equals x. So that's the relationship between those three components. All right? A gets raised to the y equals x. So we call this the exponential form because that's where we see the math, right? That's where we see the math, right? Mm-hmm. So if you need to, if you need to say find log base 2 of 8, for instance. So y equals log base 2 of 8. We've plugged an 8 in right there, right? So if you need to figure out what that is equal to, you transform it to its exponential form. So 2 raised to the y equals 8. And now you just got to figure out what y needs to be, right? So y needs to be to the 3, right? So y must be 3. So in other words, log base 2 of 8 equals 3. And so that's how logarithmic functions work, all right? You plug in the number and
it's just to find the values. It's not necessarily an equivalent form, or it is an equivalent form, that exponential form.
Yeah, yeah, that's a good question. I would say it's mostly just to yeah, it's kind of both. Okay, both.
I know a lot of them are complicated, but
yeah, it's kind of different creatures. Because what the exponential form does is it shows you the mathematical relationships behind all the things, right? So let's switch gears. So for instance, if I want to find log base 3, okay, of 81, right? So I'm plugging 81 into the log base 3 function, right? And so you say, okay, I don't know what it's equal to. We'll just say that it's equal to y. So if I transform that to its exponential form, 3 to the y equals 81, then I can see what math has to go on, right? What power do I need to throw on the 3 to make this equal? So, of course, that's going to be y equals 4, right? 3 to the 4th power, okay? And so that's what log base 3 of 81 equals. Now, that being said, a lot of times when I am doing logs, let's just say log base 5 of 25, I've done this so much, right, this little transformation so much, that what I'll do is I'll just play this game. I'll look at log base 5 of 25, and I'll just say, okay, what exponent needs to go right there to get a 25? Because that's what's happening, right? 5 raised to what power equals 25? I like doing it this way because it just keeps it all in one place. What exponent goes on 5 to get a 25? And the answer is 2, right? 5 raised to the second. So if you do it this way, you can cruise through these things quite a bit. Let's do log base 2 of 32. 2 raised to what exponent gives you a 32? So you kind of go through the powers, right? You can throw it in your calculator and go 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. Okay? And so that also helps when you're doing kind of some of the more strange ones, because remember, these are exponents. These are exponents that we're working with. So here's one, log base 3 of 1 over 27. So again, you say, what raised to 3 raised to what power is 1 over 27? And so you have to remember, oh, if I need to, I can get a 27 easy enough. That's just a 3 to the third power. But if I want it on the bottom of a fraction, it has to be a negative power, right? So you have to remember all the little ins and outs. And you just chime in anytime you've got a question here. Here's one, log base 5 of 1. So 5 raised to what power is 1? And the answer is going to be 0, right? Fill in this little box, right? Remember, so that rule of exponents, raising something to 0 power, is equal to 1. Okay. A couple other odd ones to be aware of. Something like this, log base 9 of 3. So 9 raised to what power is 3? The answer is 1/2. Because 9 to the 1/2 is the square root of 9. What's the square root of 9? 3. Right? So we have all that kind of stuff that we've got to use. So that with logarithms, that's how they work. They're amazing functions, but they are a little bit different than we're used to. All right. So let's see.
For my own curiosity, is log like a notation, or is it a value in something like pi or?
Yeah, no, log is just so obviously just short for the word logarithm.
Right.
Yeah. So it's just we've just written it down as a way of identifying a logarithmic function.
Okay.
I used the new system here. Okay. Let's see. So other highlights about logs. Now, of course, once you are able to evaluate logs, you can graph them. Okay. So, if I want to graph log base 2 of x, okay. So we would, of course, one way to do it would be to just make an XY table and start plugging things in. And let's start. So let's see real quick. Welcome, Shamiqua. Can you hear me, Shamiqua? Sorry, Peter. We're just going to check with our new guest here. Welcome, Shamiqua. Can you hear me all right? Just checking here. We're just checking with a new person here. So if you want to talk, Shamiqua, you can, you'll need to unmute your mic. And at the same time, what we'll do, Peter, is I'll have you just mute your mic when you're not speaking, now that we've got a couple people in here. Shamiqua, can you hear me? Got it. Now you're unmuted, Shamiqua. You can also use chat. Okay. Sorry, I'm chatting real lazily here because I have to use a on-screen keyboard. It's a pain. So, Shamiqua, if you could just type in chat whether you can hear me or not, that's cool. Okay, that's great. And then you can fiddle with your mic as we go along and see if you can get it to work. But right now we're just kind of going through some stuff on 3.1 or 3.2 and 3.3, just some highlights to get you guys up to speed. Okay? So fiddle with your mic, see if you can get it to work, and if it works, then you can speak to me. If not, I'll watch the chat. Okay? So I'll keep the chat up, and you can interject in chat. All right, Shamiqua? So we're graphing the log function. And so we're going to plug in values for x, just like we do when we graph everything. So the trick here is I've got to be selective on what I can plug in for x. I can't just plug in, my usual, 3, 2, 1, 0, those things. I've got to be a little more selective because the log function is not super simple to use here. All right. So adding one thing here real quick. Okay. So here's what you got to do. If I'm doing base 2, log base 2, then the values I want to plug in are powers of 2. So things like 16 and 8 and 4 and 2. Right? Now let's just see how those work. So log base 2 of 16, log base 2 of 16, remember the game, I say 2 raised to what power is 16, and the answer is 4. So 4 goes right there. Okay? Now let's plug in an 8. Log base 2 of 8. What 2 raised to what power gives me 8? The answer is 3. Okay? Log base, plug in the 4, log base 2 of 4. So you see, what 2 raised to what power is 4? The answer is 2, right? And then log base 2 of, write it down here, log base 2 of 2. 2 raised to what power is 2? That's 1, right? So no big deal. Just notice if I would have, say, plugged in a 5, right? I'm going to erase this here in a second. But I would have needed to go log base 2 of 5. 2 raised to what power is 5? Well, it's not 1 because 2 to the 1 is 2 and that's too small. It's not 2 because 2 to the 2 is 4 and that's too small. It's not 3 because 2 to the 3 is 8 and that's too big. So it's somewhere between 2 and 3. It's going to be some weird, irrational number between 2 and 3. I can't do it just like I've done these other ones in my head. I'm going to have to use my calculator. And that's too much for just graphing this, okay? So that's why I'm selectively and carefully choosing my values as powers of 2. But here's the thing. There are more powers of 2. 1 is a power of 2. Why? Log base 2 of 1. 2 raised to what power is 1? The answer is 0, right? 1/2 is a power of 2. Log base 2 of 1/2 is -1, right? 1/4 is power of 2. Log base 2 of 1/4 is -2, right? And so I could keep going 1/8, 1/16. So those are all my powers of 2. And so if I choose those as my powers, then I can easily calculate it in my head. And then I can graph it, right? That's the whole reason we were doing this, is so that we could graph this. Now I'm not going to graph 16, 4. I'll graph 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 8, 3. 4, 2. 2, 1. 1, 0. 1 half, negative 1. 1 fourth, negative 2. Here is the graph of the log function. Bam. That's log base 2. Okay. So it turns out that if I wanted to graph log base 3, all right, log base 3. Here's what I know. All logs go through. All the graphs of every log go through one. It will go through the point 1, 0. Every logarithmic graph goes through 1, 0. Right? That point right there. Okay. So I know that's going to go through there. And then the other point I'm going to go through is 3, 1, right? Because log base 3 of 3 is 1. So over 3 up 1. So those are my kind of 2 anchor points, and there's my graph. The point is this: all logarithmic graphs look basically like this. They go through 1, 0, and then they look like that. Okay. They become asymptotic to the y-axis. In other words, they never touch it. They will never cross it. You'll never see the graph over here. And they obviously go down to negative infinity. On this side, they just keep growing. They keep going, increasing, but slowly. All right. And so every logarithmic graph looks like that. They go through the graph 1, 0, and then they'll go through the point A, 1, where A is the base. Right? So those kind of the 2 anchor points. And you can shift these graphs around, right? So if I wanted to graph, log base y equals log base 3 of x plus 5, I would say, okay, normally log base 3 goes through the anchor point 1, 0 and 3, 1. And so there's just plain old vanilla log base 3. But when I stick a plus 5 on it, it moves everything up 5. So this point moves up 1, 2, 3, 4, 5. This point moves up 1, 2, 3, 4, 5. Right? So all the shifts and translations work just like they did. All right? Okay. So Shamiqua, just so you know, we're normally the purpose of these sessions is to hopefully answer a lot of your questions and to help you learn the material that you're learning. You're doing a lot of the learning on your own. And so hopefully we can use these sessions to answer your questions. What we're trying to do, if we don't have questions, then I'll, talk for a while. And so that's kind of what's happening here. We didn't have any questions, so I'm kind of trying to give you some highlights over the 2 sections that you need to get covered before we need to get on Wednesday. And then, of course, you can bring questions on Wednesday. All right. I want to mention this. And so, Shamiqua, also, if you have questions on anything, just type them in the chat. But, on this material, but of course on how you're going to learn the material yourself. Where to find the lectures. I've sent out a bunch of messages and info on that, so hopefully that's self-explanatory. Let me mention this before we move on to just talking about 3.3 ideas. We can have any base we want. Okay? Base 10 is called the common log. All right? So that's a logarithm that gets used a lot. It gets used in the decibel system, in the Richter scale for measuring earthquakes, right? In a lot of logarithmic growth problems. We use log base 10 a lot. Okay? So here's the deal. The reason I mention this is because we use it so much that we actually just stop writing the 10. So if you ever just see log, that's log base 10. You will see this on your calculator. Your calculator has a log button. That's log base 10. All right? Your calculator does not have a log base 3 or a log base 2 button. Calculator can't do those. Your calculator can do log base 10, and that's the log button. All right? So just be aware, if you just see log with no subscript, that is log base 10. We also have, in here, we also have another log that we use a lot, log base E, okay? So log base E is the natural log, right? And we use it so often, again, that we give it its own notation. It's ln of x, okay? Or sometimes you'll see it kind of written in cursive, ln of x, right? The natural log. On your calculator, I think you have an ln button, right? So your calculator can do two different kinds of logs, either base 10 or base E. So let's talk about what if you need to do a different base? What if you need to do log base 3 of 75? And that is not one you can do in your head because 75 is not a power of 3, right? Well, here, if you need to find that, you don't have a log base 3 button on your calculator. But you can change the base, all right? So you can change it from base 3 to base 10, which your calculator can do, or from base 3 to base E, which your calculator can do. Here's how it looks. The change of base formula for this particular one, if I want to go to log base 10, looks like this. Log base 3 of 75 is equal to just the log, right? There's our log base 10, of 75 divided by the log of 3. That's it. You're just going to take the log of this thing divided by the log of that thing. And your calculator can do that, right? So you just type that in your calculator, and whatever came out, that's log base 3 of 75. Same thing if you decide to do the natural log, it's ln of 75 divided by ln of 3. You can see the pattern. So using that change of base formula, you can do any log you want. So it's fine that our calculators only have two bases on them because we'll just change everything else to one of them. Okay? All right. I'm just cruising along. You guys interrupt me at any time.
I just want to ask real quick, is the idea behind logarithmic functions that they're reflections of exponentials for the most part?
Yeah, great question. Actually, what they are, logarithms are the inverses of exponentials.
Okay.
Okay, so logarithms undo what an exponential function does. Let me just show you that, right? So just take the basic exponential function base 2, right? Think about what happens if we plug some values in. So if I plug, say, 4 in there, I get out of 16. If I plug a 5, I get out of 32. If I plug a 3 in, I get out an 8, right? Now, look what happens when I do log base 2 of x. And what I'm going to do is I'm going to plug in these things. I'm going to plug in a 16, a 32, and an 8, right? So log base 16, or log base 2 of 16, 2 raised to what power 16? Bam, 4, right? So it gives us back to 4. 32, plug that in, you're going to get back a 5. 8, you're going to get back a 3. So see, they're inverses of each other, right?
Okay.
And so I listed in some of my videos that I've made some of the properties of logarithms that you're going to see. Let me just highlight a couple of them here, because how do we manipulate these and simplify them? That's kind of an important question for us. So let me show you just a couple of the properties that we have. This is the first property. And I'm just going to do everything base 10 to make it easy. First property is this. If I ever have the log of a product, the log of something times something, that can be rewritten or expanded as just the log of m plus the log of n. Okay? So you can separate, if you've got a product, the log of a product, it becomes the sum of a couple logs, just like that. Now that works in reverse as well, and in fact, reverse is how we see it most often, right? If I'm working with, log of 2x plus log of 3x, well, I can condense that down to log of 6x squared, the product of those things. that gives me the rule for combining logs. If I'm ever adding logs, I can just get one log of the product. Okay. So we also have this. If you have the log of a quotient, it's just the difference, m minus log of n. And so if you have two logs that are subtracted, log of 3z minus log of x, you can just write that as a single log of 3z over x. Okay. And that idea of going from two logarithms down to one logarithm is going to be real key when we get to section 3.4, I think, when we're solving equations that involve logs. Okay. All right. Then the last property we have is this, that if I have the log of something raised to a power, I can rewrite it like this. The power can come out and it's like, if the power just kind of floats out to the front and becomes a coefficient. Right? And so that gives us the ability to get rid of coefficients, which becomes really, really important to us when we're solving equations. So those are our properties of logs that we'll make use of. So you can see more examples of those things in the lectures that I created. So, all right. So that's kind of a brief overview of 3.2 and 3.3. Hopefully that'll add some understanding as you watch the other lectures. Like I said, I hope that with these sections we can answer more of your questions. And once you start doing these homework problems, I'm sure we'll have more questions. So anyway, I think that's about all we've got time for today. Do you guys have any questions before we call it a day and send everybody back to their bunkers?
No, I don't have anything. Are those lectures online done by you or are they from someone else?
Well, so the ones that you find in my math lab, let me do this. Let's see if we can do this real quick. Here it is. So let's just talk about that real quick. So if you go to Canvas, we'll just hit the highlights here and I'll just tell you what to expect. So the places you can learn, right? You go to My Math Lab. The lectures you find in My Math Lab are by somebody else, right? So you go to your multimedia, right there, multimedia library, and these lectures that you're going to see here are by a different person. They're a little longer. They're more like a regular lecture, right? So, but they're definitely by. Well, actually, I take that back. They've broken them down into examples, but they're not by me. Yeah. So there you go. A minute and a half. Somebody working through the examples. Okay.
Okay.
Yeah. Now, the other place that you'll find our material for this course, stuff that's prepared, is if you go to this complete online module. This is where I've got everything for our online portion right here at the top. Example videos. So these are the ones that I've made, and there are some ones on 3.2 and 3.3, right? I've just gone through some examples. And then the recorded tutorial sessions, that's where you'll find these things that we're doing right now. So after I get this done, I'll get it converted and get it posted right there for us. Okay. And just a reminder, right, so this for Chamonix, we talked about this earlier with Peter. You want to check your schedule right here in Canvas, and you want to make sure you're following along because this will show all your quizzes and your tests when they start or when they become available. All right, not when they're due, check MyMathLab for when they're due. Okay. All right, guys. Thanks for showing up. Hopefully it was a productive time for you. And, you know, we're only able to do this a couple times a week, so make sure you're here if you can be here and spread the word. So, otherwise, be safe, be healthy, take care of you guys, yourselves, and the people that you care for. So, we'll see you on Wednesday, hopefully, and feel free to contact me in Canvas if you've got questions. Okay. Okay. Have a great day.